In this video, we are going to sketch a variety of functions and then discuss the end behavior of each function. So the parent function here is clearly the square root of x. Okay, so the parent function, I'll call it p of x for the parent function, is simply the square root of x. And I know that the square root of x looks like this. It starts at 0, 0, and then it would be 1, 1. The square root of 4 is 2. Okay, so the parent function looks like this. Alright, so now let's talk about the transformations that happened. Because of the plus 3, this is left 3. And because of the plus 2, this is up 2. So I know that this is going to be left 3 and up 2. Alright, that's this point right here. I also know that because of this negative sign, there's going to be a reflection over the y-axis. That's what happens when you have a negative sign right here. So imagine swinging this like a door. It's going to swing from the right to the left. Alright, so I know that it's going to swing to the left instead, so that's going to be like this. Okay, so this is what g of x is actually going to look like. So this is g of x right here. Now we can talk about the end behavior. I'm only going to write the end behavior as x approaches negative infinity because that's the more traditional one. When you have a point, a single point, I'm not even sure you can truly discuss the end behavior. So I'm just going to talk about the one that goes to infinity. So as x approaches negative infinity, the function rises forever. So f of x approaches positive infinity. Alright, so there's the graph, and here is the end behavior. Alright, for number 8, the parent function, which I will call p of x, that is supposed to be a p. Now it looks like an r. Alright, close enough. The parent function is just x squared. This is a parabola. The parabola would have vertex 0, 0, and then 1 squared is 1, 2 squared is 4, for example. Okay, that's enough points. Alright, so the parent function would look like this. Alright, now let's look at the transformations that happened. So because of the negative 3, this is actually to the right 3, and this is up 3. So right 3 and up 3. So if I go right 3 and up 3, my new vertex is going to be here. And those are the only transformations. So I know the rest of the function is going to be the same shape as it was. Okay, so this is what function g of x is looking like. So now let's talk about the end behavior. This time we can talk about the left and the right. First, the left. As x approaches negative infinity, f of x approaches. On the left, it's going up forever, so that's going to be positive infinity. Now let's talk about the right. As x approaches positive infinity, f of x approaches. Well, it's going up on the right too, so that's also positive infinity. Alright, that's it for number 8. Alright, number 9 is a cubic function. So I know that the parent function is x to the third power. That function looks like this. Let's start with 0. Now, 1 to the third power is 1. 2 to the third power is 8. Okay, we can also do negative values. negative 1 cubed is negative 1. Negative 2 cubed is negative 8. Alright, so these purple dots show you what the parent function looked like. Okay, so the parent function looks something like that. So now let's talk about the transformations that happen. Because of this plus 2, it is to the left 2. And then it's up 1 because of the plus 1. So left 2, up 1. So if I move each of these points left 2, up 1, okay, it's going to show you what the function really looks like. I'm going to have to go off the graph a tiny bit. So g of x is looking like this. Okay, now let's talk about the end behavior. First, the left, as x approaches negative infinity. What's the function doing? On the left, it's falling, falling, falling. So it's approaching negative infinity. What about on the right? As x approaches positive infinity, what's the function doing? On the right, it's going up, 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 up. So it's approaching positive infinity. So there's your end behavior for problem number 9. Alright, what about problem number 10? The parent function is 1 over x. Now the parent function had the x and y axis as asymptotes, and I know that 1 comma 1 was a point on the parent function, alright, which you can imagine because if I plug in 1 for the denominator, 1 over 1 is 1, and I know that similarly negative 1 is a point. And like I said, we have asymptotes for the x and y axis. So parent function was looking like this. Okay, asymptote, asymptote. Okay, we had these branches. Okay, that's what the parent function looked like. So now let's talk transformations. Because of this plus 1, this is left 1. Because of this negative 2, this is down 2. So that's what I'm going to do. If I move everything left 1 and down 2. Okay, left 1 and down 2. So see where the origin is, 0, 0. If I shifted that point left 1 and down 2, it would be right here. Now there's not going to be a point here. I just want you to fix your eyes on this point because this is going to show me where my new asymptotes are. So my new x-axis will be here. Well, I mean it's not a new x-axis, but the horizontal asymptote is now here. Similarly, the new vertical asymptote, instead of being the y-axis, will be here. Alright, so you see what I mean when I said imagine moving the origin left 1 and down 2. Alright, it's the new intersection of the asymptotes. Alright, so those lines, those dotted lines are the asymptotes. Now look at the other key values, like this point right here. If I move this left 1 and down 2, that point is going to be right here. Okay, this point is going to be right here. So those two key points show me where the branches go. So I'm going to have a branch that goes like this. And I'm going to have a branch that goes like this. Okay, now it's approaching the asymptote, but it doesn't touch. Okay, even though it kind of looks like it touches, it's just getting so close that you can't see between them. Alright, now Looking at the pink lines, not the purple, let's discuss the end behavior. Let's start with the left. As x approaches negative infinity, what's the function doing? As we go to the left, this function is leveling out at -2. The function is approaching -2. As we go to the right, so as x approaches positive infinity, what is the function doing? Okay, as we go to the right, again, the function is approaching -2 from above. Okay, so there is your end behavior for number 10. Problem number 11 has two different transformations that are happening. On the inside of the function, I have this. This is actually a horizontal stretch by a factor of 3. If it were in the front, like if I had a 1/3 out there, okay, this would be a vertical compression. But inside the function, like it is, everything is in opposite land. Everything is the opposite of what it would be on the outside. So this is actually a horizontal stretch by a factor of 3. All right, let's make a note of that. So this is a horizontal stretch by a factor of 3. Okay, I did the reciprocal when I said by a factor of 3. Okay, meanwhile, this negative sign out here in the front is a reflection over the x-axis. This is complicated enough that I'm not just going to try to do this visually. I'm going to actually use a table of values to keep me accurate. So let's start with the parent function. All right, the parent function is simply x to the 3rd power. So let's make a table of values just for the parent function, and then we will make changes as needed. Let's see, I'm not sure how many values I'm going to need yet. I'm going to stick with -2, -1, 0, 1, and 2. All right, that should be enough. So when it comes to the parent function, if I cube all of these, the negatives won't go away. So this will be -8 and -1 and 0 and 1 and 8. Okay, so this is the parent function. Now, I have to ask myself, will these transformations affect the x values or the y values? A reflection over the x-axis is going to affect the y values. Any transformation outside the function is going to affect the y values. So I'm going to make a new y column based on the reflection over the x-axis. Okay, so I'm just going to make a new y column real quick. All right, so this negative sign, to do that, I just need to do the opposite of all the y values. So this is going to be +8, +1, 0, -1, and -8. All right, so that's my reflection over the x-axis. So I can forget about my old y values. I've got new y values now. Now I've got the horizontal stretch by a factor of 3. Well, horizontal stretch, well, that's going to affect the x values. Look, anything inside the function is going to affect the x values, and therefore we will need a new x column. All right, and since I am stretching by a factor of 3, I'm going to multiply all of the x values by 3. So that's going to give me -6 and -3 and 0 and 3 and 6. So now I have a new x column, so I can throw out the old x column. So these ordered pairs represent the actual function g of x, after the two transformations. So let's see what we have. I've got -6, 8. It's going to be up there. -3, 1, 0, 0, 3, -1, and 6, -8. Okay, so you can see that this function is looking like this. And now we can talk about the end behavior. Let's start with the left. So as x approaches -infinity, f of x approaches positive infinity. It's rising on the left. Now let's do the right. As x approaches positive infinity, f of x, that looks weird, f of x approaches negative infinity. It's falling over here. So there is your end behavior. Okay, that was problem number 11. Alright, problem number 12. I don't need a table of values for this. This one is very straightforward. But first of all, the parent function, which I will call p of x, is just the absolute value of x. So that function looks like this. Absolute value of 0 is 0. The absolute value of 1 is 1, 2 is 2, 3 is 3, etc. The absolute value of -1 is 1, -2 is 2, -3 is 3, etc. So that's why absolute value function forms a v like this. So this is what the parent function looked like. So what about the transformations? Because of this -2 on the inside of the function, this is being shifted right 2. Because of the -1, it's being shifted down 1. So right 2, down 1. So this vertex is going to go right 2, down 1. Alright, but the slopes of the sides of the function will be the same. It's still going up 1 over 1. Okay? Yeah, that's close enough. Got a little janky in here, but you get the idea. Anyway, look at the pink as I do the end behavior. So let's start with the left. So as x approaches -infinity, f of x approaches positive infinity. It's rising on the left. As x approaches positive infinity, f of x approaches positive infinity. It's rising on the right as well. So there is your end behavior. So that's it for problem number 12. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.